Hi everyone, thanks for clicking the video. Joseph Green here on the 22nd of June 2017. Today I thought I'd make a video compiling some independent footage of the Sun, and I'm also going to read the NASA description of what the Sun is. So the description I'm going to be reading is from solarsystem.nasa.gov/planets/sun/in-depth, and there will be a link to that in the description. The footage that I'm going to show I've taken off YouTube and it's been uploaded there in the past week. So the article on NASA website reads: "The Sun at the heart of our solar system is a yellow dwarf star, a hot ball of glowing gases. Its gravity holds the solar system together, keeping everything from the biggest planets to the smallest particles of debris in its orbit. Electric currents in the Sun generate a magnetic field that is carried out through the solar system by solar wind, a stream of electrically charged gas blowing outward from the Sun in all directions. The connections and interactions between the Sun and Earth drive the seasons, ocean currents, weather, climate, radiation belts, and aurorae. Though it is special to us, there are billions of stars like our Sun scattered across the Milky Way galaxy." Size and distance. With a radius of 432,168.6 miles, or 695,508 kilometers, our Sun is not an especially large star. Many are several times larger, but it is still far more massive than our home planet. 332,946 Earths match the mass of the Sun. The Sun's volume would need 1.3 million Earths to fill it. The Sun is 93 million miles, about 150 million kilometers, from Earth. Its nearest celestial neighbor is the Alpha Centauri, spelt Alpha Centauri, the Alpha Centauri triple star system. Proxima Centauri is 2.24 light years away, and Alpha Centauri A and B, two stars orbiting each other, are 4.37 light years away. A light year is the distance light travels in 1 year, which is equal to 5,878,499,810,000 miles, or 9,460,528,400,000 kilometers. Orbit and rotation. The Sun and everything that orbits it is located in the Milky Way galaxy. More specifically, our Sun is in a spiral arm called the Orion Spur that extends outwards from the Sagittarius arm. From there, the Sun orbits the center of the Milky Way galaxy, bringing the planets, asteroids, comets, and other objects along with it. Our solar system is moving with an average velocity of 450,000 miles per hour, 720 kilometers per hour. But even at this speed, it takes us about 230 million years to make one complete orbit around the Milky Way. The Sun rotates as it orbits the center of the Milky Way. Its spin has an axial tilt of 7.25 degrees with respect to the plane of the planet's orbit. Since the Sun is not a solid body, different parts of the Sun rotate at different rates. At the equator, the Sun spins around once every 25 days, but at its poles, the Sun rotates once on its axis every 36 Earth days. Formation. The Sun and the rest of the solar system formed from a giant rotating cloud of gas and dust called a solar nebula about 4.5 billion years ago. As the nebula collapsed because of its overwhelming gravity, it spun faster and flattened into a disk. Most of the material was pulled towards the center to form our Sun, which accounts for 99.8% of the mass of the entire solar system. Like all stars, the Sun will someday run out of energy. When the Sun starts to die, it will swell so big that it will engulf Mercury and Venus and maybe even Earth. Scientists predict the Sun is a little less than halfway through its lifetime, and will last another 6.5 billion years before it shrinks down to be a white dwarf. Structure. The Sun, like other stars, is a ball of gas. In terms of the number of atoms, it is made of 91% hydrogen and 8.9% helium. By mass, the Sun is about 70.6% hydrogen and 27.4% helium. The Sun's enormous mass is held together by gravitational attraction, producing immense pressure and temperature at its core. The Sun has 6 regions: the core, the radiative zone, and the convective zone in the interior, the visible surface, called the photosphere, the chromosphere, and the outermost region, the corona. At the corona, the temperature is about 27 million degrees Fahrenheit, or 15 million degrees Celsius, which is sufficient to sustain thermonuclear fusion. This is a process in which atoms combine to form larger atoms and in the process release staggering amounts of energy. Specifically, in the Sun's core, hydrogen atoms fuse to make helium. The energy produced in the core powers the Sun and produces all the heat and light the Sun emits. Energy from the core is carried outward by radiation, which bounces around the radiative zone, taking about 170,000 years to get from the core to the top of the convective zone. The temperature drops below 3.5 million degrees Fahrenheit or 2 million degrees Celsius in the convective zone, where large bubbles of hot plasma, a soup of ionized atoms, move upwards. The surface of the Sun, the part we can see, is about 10,000 degrees Fahrenheit, 5,500 degrees Celsius. That's much cooler than the blazing core, but it's still hot enough to make carbon, like diamonds and graphite, not just melt, but boil. Surface. The surface of the Sun, the photosphere, is a 300-mile thick, 500-kilometer thick region from which most of the Sun's radiation escapes outward. This is not a solid surface like the surface of planets. Instead, this is the outer layer of the gassy star. We see radiation from the photosphere as sunlight when it reaches Earth about 8 minutes after it leaves the Sun. The temperature of the photosphere is about 10,000 degrees Fahrenheit, 5,500 degrees Celsius. Atmosphere. Above the photosphere lie the tenuous chromosphere and the corona, or crown, which make up the thin solar atmosphere. This is where we see features such as sunspots and solar flares. Visible light from these top regions is usually too weak to be seen against the brightest photosphere, but during total solar eclipses, when the moon covers the photosphere, the chromosphere looks like a red rim around the Sun, while the corona forms a beautiful white crown with plasma streamers narrowing outwards, forming shapes that look like flower petals. Strangely, the temperature in the Sun's atmosphere increases with altitude, reaching as high as 3.5 million degrees Fahrenheit, or 2 million degrees Celsius. The source of coronal heating has been a scientific mystery for more than 50 years. Potential for life. The Sun itself is not a place conducive to living things. With its hot, energetic mix of gases and plasma, but the Sun has made life on Earth possible, providing warmth as well as energy that organisms like plants use to form the basis of many food chains. Moons. The Sun doesn't have any moons, instead it has planets and their moons, along with asteroids, comets and other objects. Rings. The Sun does not have rings. Magnetosphere. The electric currents in the Sun generate a complex magnetic field that extends out into space to form the interplanetary magnetic field. The volume of space controlled by the Sun's magnetic field is called the heliosphere. The Sun's magnetic field is carried out through the solar system by solar wind, a stream of electrically charged gas blowing outward from the Sun in all directions. Since the Sun rotates, the magnetic field spins out into a large rotating spiral, known as the Parker spiral. The Sun doesn't behave the same way all the time. It goes through phases of its own solar cycle. Approximately every 11 years, the Sun's geographic poles change their magnetic polarity. When this happens, the Sun's photosphere, chromosphere, and corona undergo changes from quiet and calm to violently active. The height of the Sun's activity, known as solar maximum, is a time of solar storms, sunspots, solar flares, and coronal mass ejections. These are caused by irregularities in the Sun's magnetic field and can release huge amounts of energy and particles, some of which reach us here on Earth. The space weather can damage satellites, corrode pipelines, and affect power grids. Exploration. A number of ancient cultures built stone structures or modified natural rock formations to mark the motions of the Sun. They charted the seasons, created calendars, and monitored solar and lunar eclipses. Modern heliophysicists research and Modern heliophysics research and exploration aims to explore the complex Sun-Earth system. This includes the Sun and its effects on Earth and the solar system, as well as the conditions in space that future explorers will experience. Thanks for making it all the way to the end of the video despite me not being able to read properly. That's me out. Peace on the plane.
The sun sets at almost midnight here in Norway now.